Hey everyone, as you can see from the title of this, this is just a continuation of the lesson that we started yesterday on factoring quadratics. And I think the target's pretty clear from the title. We're going to factor quadratics by using diamond problems and generic rectangles. All right, so the first thing I'd like us to do is take a problem from yesterday's lesson, problem 8.3, and look at it in order to find a pattern between the area written as a sum and the terms inside the generic rectangle. So take a couple of minutes to do that, pause the video, and take a look and see what patterns you can find. Right, so I hope you took a little time to see what happens here. If you look, you can see in this particular rectangle, the first term and the last term are inside the rectangle, and then the sum of these two would be the middle term. Same here. First and last are in the rectangle, and then these couldn't be combined, so basically these two middle terms are there. So in this one, all of them are there. And then in this one, the first and the third are right in the rectangle, and then the other two are the sum of the middle piece. I want to just remind you about the quadratic formula, or the form for a quadratic equation is ax squared plus bx plus c. Every now and then we'll be talking about the a, b, and c in a generic way when we're talking about factoring. Okay, so this is problem 8.14, which is the major core problem from this lesson. And it says Miguel wants to use a generic rectangle to factor 3x squared plus 10x plus 8. He knows that 3x squared and 8 go into the rectangle in the location shown below. Finish the rectangle by deciding how to place the 10x terms and then write the area as a product. Okay, so I've already put them in the rectangle for you. I do want to say that they could also be written in these two corners. And in an example that I'm going to do with you later, I put them in these two corners. I kind of like that better, but for now we're going to do what the book suggests. All right, so I want to remind you from yesterday that Cassie found a pattern that the product of the diagonals in a generic rectangle is equal, and that's always going to be true. So here's what we're looking for. We're looking for a couple of terms that are going to give you a sum of 10 that have a product of 24. Okay, so I'm thinking to myself, product of 24, huh? Well, 1 and 24, 2 and 12, 3 and 8, 4 and 6, 4 and 6. Okay, so again, I'll go through that process a little bit more, but you can see how I was just thinking there. Okay, so let's take a look at the next slide. Okay, so sure enough, 4x and 6x are the terms that you want. They add up to 10x, and they give you a product of 24x squared, which is the same as 3x squared times 8. We're going to use these patterns to help us factor quadratics. All right, so the next thing that I'm doing is looking for the area of this, the area as a product. All right, so you can see I've got a 3x written on the outside. One thing I've heard that's a really good rule of thumb is to look for common factors in each row. So looking for a common factor of 3x squared and 6, well, I know 3 goes into both of those and x goes into both of those. So there's my common factor. You can also look for a common factor in this row. This would be a little harder because 2 could go into this or 4. So if it's not clear, choose another row. You could also choose a column. All right, so a common factor between 4x and 3x squared would be x. I'll show that later. All right, or a common factor here might be 2x. So you can use a row or a column. So I chose to use the row, which is why I put the 3x out here. This will make more sense as you practice it more. Okay, so here's one thing I know. I know 3x times x gives me 3x squared. I also already talked about the fact that x is a factor of both 3x squared and 4x. So for 2 reasons, I know that goes here. So where I already had my 3x, I think the easiest thing to do to get this one is to figure out what times 3x gives you 3x squared. All right, let's see what the next one is. All right, so the other two then would be 4 and 2. Since I got my x, I know that x times 4 gives me 4x. Right, so that tells me, okay, the common factor here was 4. And now that I know that, I can say, well, 4 times what gives me 8? 4 times 2. I could also use it here, like 3x times what gives me 6x2, right? I now have my area as a product, right? So one thing I always do is just double check, make sure. I'm going to do the distributive property, but I'm also going to use the generic rectangle to check. So 3x times x, yep, that's 3x squared. 3x times 2 is 6x. 4 times x, 4x. And then when you add them together, that's 10x, yep. And then 4 times 2 is 8. So you can use the generic rectangle also to check. As long as each of these match, it's kind of like an old multiplication chart. As long as the product does match the factors on the outside, it should be correct. Okay, so what I'm going to do with this one is, this is a continuation of problem 814. I'm going to use this to actually go through step by step how you can use the diamond problems and the generic rectangle to factor a quadratic. All right, so here's the first step. And you can see I did it out on paper like a normal person, all right, instead of trying to use the computer screen. So the first step is to draw your generic rectangle and diamond. So here's my generic rectangle, here's my diamond. All right, I know that there are going to be 4 terms inside this one. So at least at the beginning, we're going to be factoring trinomials into 2 binomials. So this would be what the generic rectangle would look like. And this will be the diamond. Sometimes I've heard this referred to as an X box. You just create an X, and it would be the parts of the diamond. All right, then the second step is to write the first and third terms into the rectangle. Remember, I said I was going to start writing the first and third, or you could say first and last terms in the upper left and lower right. You'll see me continuing to do that. I think this is a little bit easier at the end when you're trying to write the binomials. All right, step 3, write the product and sum into the diamond. Okay, so what the product is really the product of the first and third terms of your trinomial. So to figure out what goes here, you just do 2x squared times 6, so that's 12x squared. And then down here is your middle term. Okay, now to find these two, we're going to consider that we're looking for something that gives a product of 12x squared and a sum of 7x. So this is the diamond, xy, and here's your x and y, and here's your x plus y. It's just you have to follow these directions to figure out what goes in the diamond. So again, multiply the first and last, and whatever the middle term is, just write it right here. All right, now determine the 2 factors of the product that will give the sum and write them into the diamond. Okay, so the way I like to do this, and I call this my thought bubble because I did this in my head, but I like to start with thinking about the factors of what we would call the coefficient here. So factors of 12. So I'm thinking 1 and 12, 2 and 6, 3 and 4. That's all I've got because I go right in order until I can't get any more. And then I'm trying to look for the pair that's going to give the sum of what I'm looking for. And you can see I'm pretty clear here that that's 3 and 4. So I just wrote them in 3x and 4x. It doesn't matter where you write these. You could write them 4x and 3x. Doesn't matter. Okay, the next step then, step 5, is just to write these terms into the generic rectangle. I just took these and copied them over here. Again, doesn't matter. I could have put the 4x here and the 3x here. Those are interchangeable. All right, step 6, determine the 2 binomials by determining what goes on the outside of the rectangle. Okay, so I've already done this here, but again, I want you to consider what I was thinking about before. So when I'm looking for this one that's up and down, right, so I'm going to start with that one first. I partly am doing that because these are prime numbers. It makes it a lot easier. The only thing they would have in common is an x, right? And then once I've got that one, then I can find this one over here, right? So this has to be 2x because I'm looking for, well, x times what gives me 2x squared, 2x. Then once I've got that one, I'm looking over here, so I've got 2x. What times 2x gives me 4x, 2. Right. Down here, I already know my x. Well, this is 3. Right, and then over here, well, since this is already 2 and 3, I'm just checking to see if that works. Sure enough, that's 6. Another thing that might have been easy is to figure out a common factor on this row first, because the only thing that goes into both of these is 3. So really just find a row or a column that works for you to easily find just one factor, and that's a good place to start. Okay, step 7, write the area as a product of 2 binomials, and then you just double check. right? So I just wrote this down as 2x plus 3 times x plus 2. There's my answer right there, and you can see I also wrote it here. So here it is as a sum, here it is as a product. I double checked, and this works. So this is how you use a diamond and a generic rectangle to help you factor a quadratic. We just factored that quadratic into two binomials. All right, I'd love to have you try these two on your own. If you don't quite have the process down, there is a great video that you can watch after you're done with this. He's great. He does like 2 or 3 examples, really shows you how to do this. I want you to try these, but I want to tell you right away before you start that one of these is impossible to do. Okay, so if you're getting frustrated, just stop. One of them is impossible. All right, so once you look at this, I think you'll see what I'm talking about. Okay, so pause this, try them and see which one can't be done. Okay, so here are my answers here, and you can see I've got my diamonds, my generic rectangles, and the first one basically ended up being 2x minus 1 times 2x minus 3. By the way, if you wrote 2x minus 3 times 2x minus 1, that's fine. That's also correct. Multiplication is commutative, so it doesn't matter what order those binomials are in. Doesn't matter at all. All right, so you can see, all right, I had my first and third terms here. Then I multiplied the two together to get this one. Here's my middle term. This time I'm looking for a sum of negative 8x, so I knew that both of these should be negative. By the way, we'll do some at some point where one is negative and one is positive, but both of these are negative. You can see my little thought bubble. All right, wrote them over here. All right, and then I figured out, okay, well, some of these have to be negative. I started with this one here. I didn't know whether it was 1 or negative 1 at first, so I did this first, and then I made some decisions about the top and the bottom. All right, there are different ways to think about that, but this did end up being negative 1. Okay, this one here becomes impossible. All right, I wrote my terms in here, then I multiplied the first and last, get negative 9x squared, 5x in the middle. So I'm looking for really one of these to be positive and one to be negative, and somehow give me a sum of 5. So I was thinking, what could be negative 9 and positive 1? No, that'd be negative 8. Or negative 1, no, that'd be 8. If this is negative 3 and positive 3, the only thing I could get here is 0, and there's no other factors. Okay, so the book said there's no possible answer to this, and I just want to say this one cannot be factored, at least not this way. We will be learning other ways to factor quadratics when this type of situation doesn't work. So I think the point here is, and this is what the CPM book was trying to point out, there are times when this method, using the diamonds and the generic rectangles, will not allow you to factor a quadratic, but there are plenty of other options we'll get into later. Okay, if you're still stuck, I'd love to have you just watch that video that I'm going to link to on Google Classroom. If you feel like you've got the process down, that's great. We'll definitely have more time that we'll be looking at this process later. All right, nice job factoring quadratics, everybody.